All right, we're back. We're on page 283, and we're about to finish up notes 20. So that's kind of exciting. I don't know if we'll do it in one video, but it's still exciting. So we want to use a change of variables, whatever that means, to evaluate the limit as h approaches 0, sine of 4h over h. Show your work / steps. Okay. So first of all, sine of 4h over h kind of, sort of looks to me like that limit I just memorized, sine of x over x as x approaches 0. By the way, classic trick question. Let me show you this. The limit as x approaches 1 of sine of x over x, right? People get obsessed with it. They're like, sine of x over x, oh, it goes to 1. It only goes to 1 if x is equal to 0 in this limit. Not equal. It's only equal to, let me say, it's only equal to 1 if you're taking the limit as x approaches 0. You're taking the limit as x approaches 1. This is just sine of 1. Like, is that useful? Nah, not really. That's why that's not a limit that you memorize, because you can evaluate it. Sine of x over x as x approaches 0, though, not as obvious. That answer is 1. That's why you have to memorize that. But that's the only weird limit that that function has. Every other one, just do by straight evaluation, and you'll be fine. Straight substitution, I guess, is what I mean. All right, so change of variables to evaluate. So what's a change of variables? Well, the current variable is h, and the typical substitution that you do is u equals something. So I'm going to try that. I'm going to say, because I see sine of 4h, and I would rather have sine of u or sine of x, basically. I want sine of x over x, or sine of u over u. I don't want sine of 4h over h. So I'm going to show you two ways you can do this. First one is I'm going to let u equal 4h. Okay, so then let's see. So that means that, okay, so like not a problem. Let's see. H is equal to 1/4 of u, or u over 4 if you prefer. As h approaches 0, what happens to u? Well, if h is approaching 0 and h is equal to 1/4 u, and h equals 1/4 u is actually a continuous function. Like it feels weird to say that, but like it is. So if h is approaching 0, u is also approaching 0. Like you get the logical value of u when h approaches 0. So I'm going to say u also approaches 0. Or 1/4 of 0 if you prefer. But like, why would you prefer that? So we can rewrite this whole thing. I can now rewrite this as so let's say the limit as h approaches 0 of sine of 4h over h is the same as the limit as u approaches 0. That's your change of variables. Your variable went from h to u. So it's this of the sine of u over h is equal to 1/4 u. So I'm going to write it as u over 4. Okay, how can we simplify that? Well, I can think of it as the limit as u approaches 0 of 4 sine of u over u, which you don't really need to show all these steps. Like, I probably would not. I can take a 4 out, constant multiple rule. It's weird how I say I probably would not when I'm writing the notes right now and doing it. And then this will be 4 times, that's the limit I memorized. 4 times 1, which is 4. Nice. Change of variables. Got it done. Okay, so the problem said to use a change of variables. So the way I'm about to do it, you couldn't have done it this way because the way I'm about to do it does not involve a change of variables. But, so this is not change of variables. So this would not have been valid to answer the question, but it will get you the solution. So, or the answer. It'll get you the answer. It's not the solution. Whatever. So start with this, the limit as h approaches 0 of sine of 4h over h. And then you look at it and you're like, 4h in the numerator in the argument of sine, so I really need 4h in the denominator because that's basically the same as having the sine of u over u. So how can I do that? Well, I can abuse the constant multiple rule. And I can do the thing that we did with trig identities. I can multiply by a very clever form of 1. It's not super clever in this case. It's this. It's 4 over 4. If I multiply by 4 over 4, what I'm going to do is I'm going to keep the 4 that's in the numerator on the outside. So I get 4 limit as h approaches 0 of sine of 4h over, I'm going to take this 4 that's on the outside, that's the wrong color, and bring it in. 4, too much switching, 4h. Okay, once we have the sine of a thing over itself, if the thing is going to 0, so if h goes to 0, 4h goes to 0. So once we have that, we know that that limit is 1. So this will just give us 4 times 1. Too much switching, which equals 4. And you have your answer. That's actually the way I would probably do the problem if someone gave it to me. I'd be like, oh, I know how to do this. I'll just multiply by 4 over 4 and be done. But if the problem says use change of variables, you have to show this stuff so that we can actually change the variable. So it's kind of up to you if you're not told what to do, but if you're told what to do, you have to do what you're told to do. Life, right? That's how it goes. All right, let's look at this one. So here, we have the limit as h approaches 0, sine of h over 4h. This is like a little different because the 4 isn't inside the argument of sine. So we can just do whatever we want with it. I'm just going to take it out right away. 1/4 limit as h approaches 0, sine of h over h, which is 1/4 times 1, which is 1/4. All right, there you go. I touch my face all the time in these videos. It's a little alarming. All right, let's see. Next one. This problem really should say like as x approaches 0 from a side. So what I'm going to do, I'm going to squeeze in a little plus here. Let's approach 0 from the right. The reason that I want to do that is the limit as x approaches 0 overall for cotan doesn't exist. So I'd have like something times doesn't exist. Doesn't really make any sense. But if I make it 0 from the right, now it does exist, so we can like think about it. So the first part, x is definitely approaching 0. Let's see what cotan does. So quick review of cotan. So cotan, pi over 2. I have a 0 here because tangent has a vertical asymptote there. And then it does this. It kind of looks like a negative tangent graph, but it's not because it's cotan. And also it's a negative tangent graph, but it's shifted over by pi over 2, I guess. So the limit as we approach 0 from the right is infinity. Okay, so that's pseudo indeterminate. We got to do something. So what should we do? I think we should do some trig stuff because it's the only option, right? It's not a hard choice. So it's x. I'm going to turn cotan into cosine over sine. Okay, so we're taking the limit of this whole thing. So provided all of the limits exist, I'm allowed to like break this up in various ways. I see a good way to break it up because I see an x in the numerator and a sine in the denominator. So let's mix those, right? So let's do limit as x approaches 0 of x over sine of x. So according to the limit laws, I'm allowed to do this as long as the limits exist. If the limits don't exist, I'm not allowed to do it, and I'll erase it and try a different thing. But if they exist, then why not do it? Here. All right. From the right. Okay. We memorize the first one. We know that that's 1. And then the cosine's a continuous function, so you can evaluate limits by direct substitution. Cosine of 0 is 1. So this answer is 1. And we got it. Okay. You know what I'm going to do? I'm going to stop this here and come back because the next problem is going to take a little bit of thought, and then the one after it is calculator and also blows my mind, and so I'm probably going to talk about that for like a minute, and then the final one, and then we'll be done. So I will be back to do that in the next video, and I will see you then.